Hello friends, welcome to today's episode. In today's episode, I want to show a very interesting problem on congruent triangles which I came across while taking my tuition classes for a 9th standard student. It's a question from one of the books that I practice from, and I hope that you enjoy the problem. I would highly recommend that once you listen out to the problem, you try to solve it yourself. Give yourself about 15 minutes time to solve it. If you don't get it, go through the solution that I present. And after understanding the solution that I present, you solve it once again at your end. That will help you remember the solution to the problem and also understand the solution in a little better fashion. All right, so let's start. Great. So the problem goes as such. What I'll do is I'll draw out the problem and I'll tell you what the words of the problem meant. We are given a triangle. All right. Such that it is given angle B is equal to 2 times angle C. We are also given AD is angle bisector such that TC is equal to AB. All right. So we are given this in the question. And the question goes, angle A is equal to what? Fairly simple, easy, complex. Well, we know that the sum of interior angles of a triangle is 180 degrees. So angle A plus angle B plus angle C is 180 degrees. However, we are given a relation between angle B and angle C, but we don't have a relation between angle A or C or A or B. So we have two unknowns in this question, and we need to find one more relation for us to be able to solve the question better. As per the diagram that I drew, doesn't it somewhat look like ABD is an isosceles triangle? It does. Well, it always helps to draw such diagrams to scale as much as possible so that we get a starting point to start solving the question. It's also given that angle C, let's call this as X, this as Y, and this as Y. So angle B is 2X. Angle A is 2Y. Angle B is 2X. Angle C is X. All right. So we have 2Y plus 3X is 180 degrees, sum of interior angles. Now, let's proceed to solving the problem. Whatever I'm going to draw in blue are going to be the constructions that is going to help me solve the problem. All right. This symbols just mean that DC is equal to AB. Perfect. So I constructed the bisector of angle B, and I join DE. Now, let's pay special attention to triangle EEC. This is X and this is X. Hence, angle EBC is equal to angle ECB. So that will give me EB is equal to EC, property of an isosceles triangle, which will mean we have one relation here. The other relation that we have is AB is equal to quick DC. We have got two relations. EB is equal to DC and AB is equal to DC. Now, I want us to pay special attention to this triangle and this triangle. I want us to pay attention to triangle ABE and triangle DCE. We know angle ABE is equal to angle DCE is equal to X. DC is equal to AB given, and we have also shown DE is equal to EC through construction. Can you visualize an SAS congruency? Excellent. Since AB and DC are two sides, BE and EC are two sides, and the X angles are included within these two sides, by SAS congruency, we have triangle ABE is congruent to triangle DCE. Pay special attention to the way we have written, because AB is equal to DC, BE is equal to EC, and these angles are equal. So through this, what we get is this. Triangle ABE and DC, the angles were equal. Let me just draw a figure on the side for us to refer to anytime we want. This angle, this angle, this is equal to this. And we have shown this side is equal to this side. We are working with this triangle, and we are working with this, right? So this is what we get so far. Now, from CPCT congruency, we can say that DE is equal to AE. With me so far? DE is equal to AE. DE is equal to AE. Right? Now, let us pay special focus to triangle AED. How will triangle AED look? I have drawn it on the next page, where I'm going to quickly take you in a few moments. This is how triangle AED look. And since AE is equal to DE from the congruent triangles, we can say this angle is equal to this angle. Also, by exterior angle theorem, we will be able to, let's call this angle as alpha. Alpha is equal to, and this was y, right? This angle in our previous question in AED was y. So I'm going to highlight this angle as y. And since this is y, alpha is equal to sum of two interior angles, y plus y, which is 2y. All right. Now, what is this alpha? If we look here, if we now focus on the triangle AED, this is triangle AED, and this is the exterior angle, which is nothing but angle DEC. So we have angle DEC is equal to 2y. With me so far? Amazing. Let's go to another triangle now. Let's come back to our initial triangle BEC. All right. Now, on the first page of triangle BEC, we have the exterior angle here will be equal to sum of these interior angles. So what I'm going to do is just replicate this figure on the next page here. So we have angle BE, exterior angle here is equal to sum of these interior angles. With me so far? All right. Now, for our understanding, what is the exterior angle in the figure? For BEC, it is BEA. So, angle BEA is equal to 2x. I'll show this once again. For our figure BEC, this is the exterior angle BEA because AC and AE are the same line. Similarly, for triangle AED, angle DEC is the exterior angle. Here we got angle DEC is 2y, and here we got angle BEA is 2x. So angle BEA is equal to 2x, angle DEC is equal to 2y. With me so far? All right. Now let's come back to our congruent triangles. We have triangle ABE is congruent to triangle DCE. All right. This was our initial figure. I will just undo the black lines for us to understand it better. ABE is congruent. ABE is congruent to DEC, which will give me angle AEB is equal to angle DCE DEB, which will give me 2x is equal to 2y, which will give me x is equal to y. We have one more relation between x and y. From our initial interior angles in a triangle, we had 2y plus 3x is equal to 180 degrees, but x is equal to y. So the entire solution boils down to 2y plus 3x is equal to 180 degrees, or 5x is equal to 180 degrees, or x is equal to 36 degrees. So what we get? We get x is equal to 36 degrees, angle DAC, which is y, angle BAD, which is y plus y is angle A. Angle A is equal to Angle A is equal to 2y, which is equal to 72 degrees. Perfect. I'll quickly walk through the proof once again on the main diagram for us to understand it better. I would really urge you to solve this problem yourself. And once you go through the proof, solve it again. In the question, ABC is a given triangle such that angle B is 2 times angle C. Hence, I have taken angle B as x and x. And the bisector of angle A meets the triangle meets BC at D. So I've taken angle BAD is equal to angle DAC is equal to y. My construction involved constructing angle bisector of angle B, DE, hence x and x, and joining DE. Now, in triangle EDC, since this angle is equal to this angle, we have DE is equal to EC. We are also given DC is equal to AB and angle ABE is equal to angle ECT. By SAS congruency, we get ABE is equal to DCE. All right. ABE is equal to DCE. From this congruency, we have AE is equal to DE. AE is equal to DE. So for triangle ADE, angle ADE is equal to y, since DEA is equal to y. All right, because AE is equal to DE. So the exterior angle, which is nothing but DEC, is 2y. Same way, if we look at triangle BEC, angle BEA is the exterior angle of these two opposite angles. So BEA is equal to 2x. We have DEC equal to 2y and this equal to 2x. However, since these two triangles are congruent, 2x is equal to 2y and hence x is equal to y. Substituting that here, we get y is equal to 36 and 2y, which is angle A, is 72 degrees. All right, quite an intense proof, isn't it? Do try it. Leave any queries that you have in our comment section and I will revert on the queries. Thank you.